Now here's a very, very interesting problem. Instead of 2-point charges, now we have 3-point charges. And it says, suppose 3-point charges are located at the corners of a rectangle. What is the electric field at P due to the 3 charges? What is the acceleration of the electron located at P? And assume no other forces other than electrical force acts on the system. So I'm going to just give you a few examples, and I'm just going to assume something. So what it's saying is, let's start with electrical field due to 3 charges. So I'm going to just charge Q, 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 and I'm randomly just going to use this as my reference point P. I can call this one Q3, this one Q1, and this one Q2. Call this 6, call this 4, call this -1, and this will be my point, okay? And I need to calculate electrical fields due to all of these at this point P. Now, this is a positive charge. I should have probably left this alone. This is a positive charge. This, on the other hand, is a minus charge. This means that E due to this one is going to be pointing inwards, right? So E3 goes inwards, Q1 goes outwards, and Q2 also goes outwards. So E2, E1. At this point P, E1 will be that way, E2 will be that way, and E3 will be that way. I try to make sure that the vectors are kind of irrelevant right now because they all will depend on the charge, because E is actually KQ over R squared. So we'll figure it out, right? So what do we need to do first? Let's just do a quick calculation. What is going to be E1? E1 is going to be KQ1 over R1 squared. E2 is going to be KQ2 over R2 squared. And E3 will be KQ3 over R3 squared. So right now I'm not really concerned, but if you want to plug in numbers, so I'll just give you some random numbers. Call this 2 meters, call this 5 meters. That's a really large number, actually. So instead I'm just going to call them 0.2 meters and 0.5 meters, just as a random number. What do we know? Well, R1 here, R1 is easy because it's just going to be 0.5 meters. R3 is also easy because it's going to be 0.2 meters. R2, on the other hand, is going to be interesting because this is actually this distance here. How do we find that distance? Yes, Pythagorean theorem. So it'll just be 0.2 squared plus 0.5 squared square root. I calculate it to be 0.539, but please make sure that you recalculate it so that you get the exact value. Okay? Once you plug in these numbers, you are going to come up with actual numbers for E1, E2, and E3. I'm not going to worry about that. What I actually want to do, what I want to do, is talk to you about what is the EP here. What we need to do now is, since this is vectors, we need to again go back and figure out all of EX and all of EY square root. And that's not it. That's just the magnitude of it. We also have to figure out the angle, which is going to be tangent inverse of EY over EX. So now how do I find EY and EX? That's my job for today. What is going to be EX? EX is going to be E1 x plus E2x plus E3x. And EY is going to be E1y plus E2y plus E3y. Okay? How do I find this? Well, the first one is only going to have a component along the x-axis. So I'm going to only have E1x. Actually, let me just split it up. So this one is going to be E1x, which is going to be just E1, and E1y will just be 0. Why? Because it doesn't have a component along the y direction. Okay? Same thing when we talk about this. This is going to only have the component along the y direction. So this will be E3x will be 0, and E3y will be, I think I calculated to be 1.8 times 10 to the 5 minus newtons per coulomb, but you can recalculate it. And this one, I get 1.14 times 10 to the 5 newtons per coulomb. Okay, E2 on the other hand is going to be interesting, because E2 will have components along x and y. So E2x will be E2 cosine theta, and E2y will be E2 sine theta. Now how do I find theta? Theta is going to be this one. So my theta will be 0.2 over 0.5. Let me just do tangent. That might be the easiest thing to do. So tangent of theta will be 0.2 over 0.5. I calculate the angle to be about 22 degrees for me. So theta is going to be approximately 22 degrees. Once you plug in that value, actually you should probably calculate the correct one. So once you plug in those values, you will have all of these numbers that can be brought down and solved. Plug them in here. Once you have them, plug them in here, and you can calculate angles and the field. So be very, very careful. When you go do problems like this, make sure that you do a vector calculation. These are not scalars anymore. Now what about part B? It says, what is the acceleration of the electron located at point P? So what if I would actually figure out that I will put an electron here? So an electron will be a negatively charged particle. How will this accelerate? How do I do this? So for part B, I know sigma F is equals to QE. The only force that's acting on the systems is basically the force due to each of these charges. So I will have force due to, this is going to be my force that's going to be on it. It is going to accelerate, so mass of the electron times the acceleration will be QEP, and acceleration will be QEP over m. You can calculate EP from part A. You know mass of an electron is going to be 9.11 times 10 to the minus 31 kilogram. And the charge on an electron, you should know 1.6022 times 10 to the minus 19 coulomb. And accordingly, my EP, when I calculate it, comes out to be 3.5 times 10 to the 5 newtons. Okay, plug them in, calculate for A. So this way of adding the electrical fields, as we have been doing, is called principle of superposition. Another way of looking at it is if you were to add all the forces due to all the charges present on a test charge, the net electrical field at the position of the test charge will just be E1 plus E2 plus E3 plus E4 up till En, if there are n number of charges. In a nutshell, here's what you need to worry about. So comparing gravitational and electric field. The sources for gravitational field is the mass. The source for an electrical field is a charge. So if the mass was not present, gravitational field would not be there. If the charge was not present, then electrical field will not be there. What creates the field is the G or the E, electrical field or the gravitational field. And mathematically, it's going to be K, Q over R or G, M over R squared. And who feels it? Another mass will feel the gravitational force, another charge will feel the electrical force. Okay, so you need both of these things. You need a charge So for a gravitational field, you need a mass to create the field that another mass will experience. For electrical field, you will need a charge to create a field that another charge will experience.